Welcome to our Quantum Deep Dive. Today, we're exploring a fascinating essay by Jörg Oa Schneppet called Anti-Up-Squark, a supersymmetric quantum puzzle, and we're going to try and understand one of the most elusive particles in all of theoretical physics.
We're starting this explainer with a huge cosmic mystery, because really, the story of the Anti-Up-Squark is a detective story. It's all about the massive gaps in our understanding of reality itself.
Okay, let's dive into this. Here's our roadmap for the investigation. We'll start with the loose ends of the standard model, then look at the theory of superpartners. After that, we'll build a profile of our main suspect, this ghost particle, then we'll follow the hunt for it, and finally, ask what it all means.
First up, let's examine the scene of the crime, the standard model of particle physics.
On the one hand, this is one of the most successful theories in the history of science. It beautifully organizes all the fundamental particles that make up, well, everything we can see and touch.
But, and this is a huge but, it has these gigantic unanswered questions, big loose ends that tell us the story just isn't complete. It's kind of like a puzzle with some absolutely crucial pieces missing.
Okay, so let's see how this builds. To solve these puzzles, physicists came up with a pretty radical and, really elegant new theory.
It's called supersymmetry, or SUSY for short. The core idea here is that the universe has this hidden symmetry, a whole new layer of reality that we just haven't been able to see yet.
You see, in the standard model, particles fall into two very distinct families. You've got the fermions, which are the building blocks of matter, and then you have the bosons, which carry forces. They kind of live in separate houses.
But what SUSY proposes is that every particle we know has a superpartner in that other family. It's like a cosmic stunt double, but with a different spin. And what this does is it brilliantly doubles the entire particle zoo.
So, here's the crucial point. If SUSY is real, then a whole new set of particles has to exist. And our investigation is now going to focus on one key suspect, the Anti-Up-Squark.
First, let's just break down that name. It really tells you everything you need to know. Anti refers to its antimatter property. Up connects it to the common up quark, and squark, that's just the name for the superpartner of a quark.
Now what's really interesting here is the comparison. The Anti-Up-Squark mirrors its partner in some ways, like its relationship to the strong force, but it's also fundamentally different in its spin and its charge.
Okay, so a particle with these specific properties should leave some kind of trace, right? For more than a decade now, a global manhunt has been underway at places like the Large Hadron Collider.
So far, the search has come up completely empty. And this has allowed scientists to set a lower limit on its mass. So if this thing exists, it has to be heavier than 1.5 tera-electron volts, which would make it an incredibly massive particle.
Finding it isn't easy, mainly because it's so unstable. What scientists actually look for is its decay signature. That looks like a spray of particles, which they call a jet, plus, and this is the crucial piece of evidence, a large amount of energy that just seems to vanish from the detector.
So let's see how this all builds up. The fact that we haven't found the Anti-Up-Squark, or any of its relatives for that matter, raises some really profound questions for the world of physics.
This quote from Schneppet's essay really captures the core dilemma here. Supersymmetry it's a beautiful theory. It solves so many problems, but where is the physical proof?
Well, the lack of evidence has forced physicists to start considering other possibilities. Maybe our colliders just aren't powerful enough yet. Or maybe nature just chose a completely different path to solve its mysteries.
And you have to understand, the stakes here are incredibly high. Finding the Anti-Up-Squark wouldn't just confirm one new particle. It would validate a theory that gives us candidates for dark matter and helps unify the fundamental forces of nature. It would be a game changer.
And ultimately, all of this leaves us with a final, really provocative question that physicists are grappling with right now. Because what we find, or what we don't find, is going to change our understanding of the entire universe.
Thank you so much for joining our deep dive into the quantum puzzle presented in Jörg Oa Schneppet's work. For more, you can always visit schneppet.de. Goodbye for now.
Schneppet.de is a private project by Jörg Oa Schneppet dedicated to promoting quantum technology. Its mission is to present knowledge in a way that is clear, precise, and transparent for those just starting out, as well as for experts who wish to deepen their expertise. He firmly believes that education and access to well-structured information are the keys to unlocking the full potential of this future technology. If his work helps you realize your own visions and actively and consciously shape quantum technology, then the goal of his project has been achieved.